Hey guys, welcome to our Unit 9 test study guide. Let's go ahead and get started here. For the most part, I'm going to be doing the even problems, and that's all I'm going to ask you guys to do as well. For the first set, I'm going to do all of them for the first few just because they're pretty quick and easy. You're going to want to remember your log properties in order to be successful on our test here. So you'd want to look at lesson 9.2 and take a look at all of those properties that we listed out. One of our properties says that anytime these numbers match, the answer is 1. Okay, let's go ahead and take a look at number 2 here. In this case, they don't match, but we can do a nifty little move here. I can rewrite this 4 as a 2 squared, and for that, we do have a property. These kind of cancel each other out, and I'm just left with 2. Let's go ahead and take a look at number 3. Same property, actually. This is a common log. Whenever you don't see a little base right here, that means it's 10. And once again, these just cancel, and I'm left with x. Right? ln, as you guys hopefully know, is a log with a base of e, and 1 over e is just e to the negative 1. And so these cancel, and my answer is negative 1. Next one here, you could rewrite that square root of 5 as 5 to a half power. And they'll cancel, and you're left with a half. So as you guys can see, the strategy here is pretty much try to get whatever's here to have the same number as here. And then once you got that, you can use the property where you cross these off and you're just left with the exponent as the answer. All right, let's go ahead and take a look at one more here. For a logarithm, you can't have 0 or negative here. So when you see that, that is no solution. That's another one of our log properties. Another one of our log properties says that anytime you have a 1 here, the answer will simply be 0. And once again, as I said earlier, you can't have a negative here, so that would be no solution. All right, so for number 9, we want to expand the logarithm. For that, we're going to use our log properties that say that anytime you have two things that are being multiplied together, you can rewrite those as two logarithms, separate logarithms, that are being added together. Also, when it comes to seeing square roots, we like to rewrite those as half powers. Now we have another log property that says that anytime you have an exponent, you can throw it to the front of your log. And just so you guys know, on your test, they're not going to write that one in that way. Instead, they're going to write it like this. And that would be the final answer there. Okay, and so these are the log, this next few problems are going to be the log properties that we had in lessons 9.3. So you might want to look at those properties if you're forgetting what those are. Let's go ahead and take a look at another one here, number 10. Sometimes you'll see these expressions with a power here. Before you begin, I would recommend distributing that power into the logarithm first. So I end up with a to the 24th power over b to the 6th. Now, we have a log property. Anytime you have a fraction in here for the argument, you can rewrite that as two separate logs that are being subtracted, where the one on the top comes first, the one on the bottom comes second. And actually, I have a boo-boo here. This is not supposed to be 4, it's supposed to be 6. My bad. And then finally, we can use that other log property. It says you can toss these exponents up here to the front. And so we have 24 log base 5 of a minus 6 log base 5 of b. And that would be our final answer for number 10. go ahead and take a look at number 11. So number 11 and 12 are going to be the opposite of what we just did, which is instead of expanding, we're actually going to work backwards and condense it back down. So for number 11, the first thing I want to do is I'm going to rewrite this a little bit, where instead of doing that, I'm going to rewrite that as half times log base 3 of a. Now, working backwards, then the number in the front can be written as a power on the argument. So we have log base 3 of c to the 5th plus log base 3 of a to the half. And next, when you have two logs being added together, you can combine those together into a single logarithm where their arguments are being multiplied. And then finally, the half power can be rewritten as a square root. And that would be our final answer for number 11. Let's go ahead and take a look at number 12. For this one, I'm going to take the exponents and move them as powers onto the arguments. Next, since we're subtracting, we have a log property that says that those two arguments, or those two logs, can be combined into one logarithm where you divide the first argument by the second argument. And there's that. All right. Let's go ahead and move on to number 13. Looks like I'm just ending up doing all of them. We'll see how it goes. All right. So this one is asking us to find the inverse of the function. So the first step is to switch the x and the y around. Then after that, we want to be getting the y value by itself. So after you switch the x and the y around, we're going to go ahead and exponentiate both sides using this base. And so that means we're going to write this base here on each side of an equation, where this side is the power on that one, and this side is the power on that one. And the reason we do that is because that 5 will cancel out that log. Because remember, our goal is to get the y by itself. So now I've got the y over there without the log on anymore. The next thing I want to do is I want to get rid of that 3 as a power there. So what I'm going to do is I'm going to raise both sides to the 1/3 power, because 3 times a third is 1. So we end up with 5 to the x over 3 power equals y. And that would be our inverse of this function here. Let's take a look at another one here. All right, step 1 is to switch the x and the y around. Now, an important difference to be aware of here is the fact that there are no parentheses. If we had this, I would have to get rid of the log first. But without the parentheses, we're actually going to get rid of the 9 first. That's an important detail to be aware of, because our goal is to get the y by itself. So to do that, the first thing we want to do is get the log by itself. So I'm going to move that 9 out of the way. And now to get rid of the log, I'm going to exponentiate both sides using a base of 3. So the left side becomes 3 to the x minus 9, and the right side becomes 3 to the log 3y. So, and on the right side, these cancel, and that pretty much leaves me with my final answer there of y is equal to 3 to the power of x minus y. So, switch the x and y, get the log by itself, exponentiate, solve. Let's go ahead and take a look at another one here. Notice we have parentheses this time. Step 1, switch the x and y around. Now, on this one, I'm not going to get rid of the 5 first. The reason why is because that 5 is in parentheses with the y, and therefore it's part of the log. So I need to get rid of the log before I can get rid of the 5. So I'm going to exponentiate both sides to get rid of the log using a base of 4. So that's going to be 4 to the x is equal to 4 to the log base 4 of y plus 5. On the right side, this 4 cancels out the log 4. I've got y plus 5 here. And to get y by itself there, all we have to do is minus the 5. So final answer there is 4 to the x minus 5 equals y. All right, let's move on to number 16. Want to continue the practice of finding some inverses here, so I'm going to switch the x and y again. All right. Now to get the y by itself, what I want to do is I want to get rid of this 5 base here. The way we're going to do that is by logging both sides with a base of 5. So it's going to be log base 5 of x is equal to log base 5 of 5 to the y over 5. And on the right side, this log 5 cancels out that 5, leaving me with y over 5, like so. And the last thing I'm going to do here is just multiply both sides by that denominator to get rid of the 5 on the right side. And so final answer there will be y is equal to 5 log base 5 of x. All right, and just so you know, it's possible that they won't stop there. They might use a log property that says that if you have a log being multiplied by a number, you could technically move that to become a power on the argument. So it's possible they would write the answer like this as well. So the answer could come in either way, but just giving you a heads up there. Let's go ahead and move on to number 17. Got another inverse problem. So once again, switch the x and y. First thing I want to do to get the y by itself, so I'm going to move that 5 out of the way. Now I want to get rid of the 3. And anytime you want to get rid of a number that's a base of an exponential expression, you're going to log both sides with that number as the base of the log. So I'm going to use log base 3 of this whole side. Now since it's the whole side, I'm going to put that in parentheses. And on the right side, the log 3 cancels out the 3 like we wanted, and we're left with just y. And there you have it. Number 18. Another inverse. Switching the x and y around. On this one, I want to get rid of the e. And when you want to get rid of an e, you need to log both sides. The way we do that is with an e is with an ln. So we're going to ln both sides. Ln e cancels. Left with y over 5. And we're going to multiply both sides by 5. And so I'm left with 5 ln of x equals y. And be aware, once again, that we can take this 5 and make it a power of the x there. And that'll be it. Take a look at another one here. Now, we're moving on to a different type of set now. We're moving into the process of finding answers to equations. So for these ones, you want to be aware of your domain. So whatever the argument is, it has to be greater than 0. So in this case, x has to be greater than 0. So whatever answer I get, it needs to be greater than 0. Now, how do you solve log equations? After you find the domain, you want to get the log by itself, which it's already in that state. And then you're going to exponentiate both sides to get rid of the log. And you're going to use this number here as the base of exponentiation. All right, so on the left side, the 2 and the log 2 cancel, leaving me with x. And on the right side, I've got 2 to the third, which is 8. That's a good answer because it is, in fact, greater than 0. It fits my domain. So we'll keep that as a solution. Let's take a look at yet another question, number 20. In this case, whenever you have a log on both sides, it's really quite simple. You just drop the log off. Now, I didn't start by finding my domain, and I really should have. I'll go back and do it at the end, though. Plus 4m and I end up with m equals -6. Now, we have to make sure that this answer is allowed by checking our domain. So we want to see is 4m minus 6 needs to be greater than 0. So I'm going to go ahead and solve that. Don't forget, when you divide by a negative, when you're working with inequalities, it reverses the arrow. Also, in these cases, it's a lot easier just to work with fractions here. So 6 divided by 4, it's going to be -1.5, is it? 1.5? Okay. So is this number less than 1.5? Yes, it is. So far my answer looks good. But we have to check this one also. -3m also needs to be greater than 0. And once again, we're dividing by a negative. So that means that m needs to be less than 0. And once again, that still works for that one too. So since my answer works for both domain restrictions, then we're in good shape. And this is my answer. And just so you guys know, technically you don't really need to check your domains on problems unless there are these ones where you have a log on both sides. Those are the ones where you tend to end up with extraneous solutions. There's another one too, the ones that give you quadratic equations. Those are the two type you got to watch out for. Let's go ahead and check out number 21 here. So I'll start off right this time by checking my domain and do the -9x minus 1 greater than 0, and the x squared plus 7 is greater than 0. So starting here with this guy, we're going to add 1 on both sides, divided by -9. Switch the arrow because I did divide by a negative, and I believe that's going to be like -0.1 with a bar over it. It just kind of keeps going. So there's that one. So I know my answer needs to be less than a -0.1-ish. So let's go ahead and take a look at the next one here. This one has a few interesting things happen along the way. Interesting thing number 1 is when you're solving, you have to take a square root. And with inequalities, when you solve by taking a square root, you get two answers, one where the arrow is opposite, one where the arrow is the same. For the one with the same, you take the positive version of your answer. And for the one where it flips, you take the negative version of your answer. So that's interesting thing number 1. And it can be either one of these. It doesn't have to be both of them at the same time. It could just be one or the other. The other interesting thing about this solution is the fact that we're taking the square root of a negative, which means actually there's no solution to that, and therefore this does not give us any domain restrictions. So if you ever end up taking the square root of a negative, just know you can ignore that one because it doesn't exist, and therefore it doesn't create any domain restrictions. So the only one I need to really pay attention to is this guy. X has to be less than -0.1. So let's go ahead and solve it. We're going to go ahead and drop the log 15 off both sides. Now, this is a quadratic equation. When you have an x squared, that's a quadratic. And when you have a quadratic, what you want to do is you want to move all the terms to one side. So it equals 0 on one side. After that, you can either factor or use the quadratic formula. Personally, I prefer factoring. So let's review factoring for a second here. I like to put the first number here, last number here. Oh, this was supposed to be an 8, by the way, not a 1. All right, so what times what makes x squared? Well, that would be x and x. And what times what makes 8? Well, there's 4 and 2, but I already know the answer is going to be 8 and 1 also works, and that's the one that's going to work. So I'm going to go ahead and put that there. And so you know you're right when these numbers add up to make the middle. 8x plus 1x does in fact make 9x. So that's the correct pair. So we have x plus 1 and x plus 8. Then you go ahead and set each one of those equal to 0 and solve. So there's my answers. And we want to make sure it works. Remember, our domain was x has to be less than negative 0.1. And both of these are less than negative 0.1. So they're both good answers to keep. I'm going to take a look at number 22. All right. There's a lot of stuff going on here. What we want to do is begin by getting the logarithmic part by itself. That's this whole thing here. So I need to get rid of this negative 4 and this negative 3. So to get rid of the 4, I'm going to add it on both sides. And then to get rid of the negative 3, I'm going to divide that on both sides. Once you got the log by itself, you're going to exponentiate. And then on the left side of the equation there, the 11 cancels the log. Eleven to the third power is going to be a really big number. It's going to be 1,331. So we'll go ahead and add 9 now. And then divide by negative 6. And this number can be reduced. If you divide the top and the bottom by 2, you're going to get 670 over 3. And it is a negative because there's a negative on the bottom there. So there's that one. But move on to, oh, you know what I didn't do? Did not check my domain. Let's check that domain. I tend to forget that. And just so you guys know, this is one where you really wouldn't have to check the domain. So maybe I'll skip it this time. And the reason being is because, like I said, you only have to check the domain when you have those problems where it's a log on both sides of the equation, or if you have a quadratic, and none of this was either one of those. So just so you guys know, if you get an answer with these types, it's going to work. So I'm going to go ahead and skip it this time. Let's go ahead and take a look at number 23. Now this is another type of problem where you have two logs, but they're on the same side, and notice they're being subtracted. For those types, we're going to combine those into one logarithm using our log property, where you take the argument of the first one and divide it by the argument of the second one. All right. After that, we're ready to exponentiate both sides with a base of 3. So this whole thing becomes a power here. And this becomes a power here. These cancel each other out, leaving me with 5 over negative 3x. And this is 27. Now when you have these kinds of fraction problems, what you're going to want to do is you're going to want to multiply both sides by the denominator first. So I'm going to multiply by negative 3x. On the left side, those cancel, leave me with 5. And on the right side, I'm going to end up with negative 54, I think is what that would be. No, sorry, it's going to be 81 actually. Right? I think so. Let me check on that just a second. Negative 81x. And then you just divide both sides. And once again, Not really much of a need to check your domain with this type of a problem because once again, you don't have a log on both sides of the equation, and neither did I end up getting a quadratic, so we're good to go. Let's go ahead and move on to number 24. Once again, I don't have a log on both sides of the equation, and also, well, we might have a quadratic here, so we might have to check our domain. Let's go ahead and see how this works out. So we do have a quadratic in there, right? So we might want to check this out. So x squared plus 2 needs to be greater than 0. Now we saw this earlier today in this study guide, but we'll see it again here. When you have an inequality and you're solving by taking a square root, you get two answers, one where it's less than and one where it's greater than. And the one that's less than is the negative version, and the one that's greater than is the positive version. But once again, we have a square root of a negative. When you have a square root of a negative, that means there's no solution, which means that there are no domain restrictions, which means that x can be anything. So we're good to go and we can start solving this. So once again, I've got two logs that are being subtracted. So we're going to write that as one logarithm, where the first argument is being divided by the second argument. We're going to exponentiate both sides with a base of 2. That becomes the power on this side. And this becomes the power on that side. On the left side, these cancel, leaving me with x squared plus 2 over 3. And on the right side, we have 4. And once again, when you have an equation that has a fraction, you might want to get rid of the fraction by multiplying both sides by the denominator, because that cancels the denominator out. So I've got x squared plus 2 equals 12. I'm going to go ahead and minus 2 on both sides there. And then I'm going to take a square root. And don't forget, when you solve by taking a square root, you do get a plus and a minus answer. And since there were no domain restrictions, I know that both of these answers are valid. So we can keep both the positive square root of 10 and the negative square root of 10. Take a look at number 25. So these are exponential equations now. The way you solve exponential equations is by getting rid of the base so that you just have the x left. And the way that you get rid of the base is by logging both sides. And your logarithm should have a base that matches the number that you're trying to get rid of. So in this case, I'm going to log base 14 both sides of the equation. The left side, these cancel out, which is the reason I did it. This side over here, we're going to use the change of base on that, where you do log of 83 with a base of 10 divided by log of 14 with a base of 10. And from there, it's going to be a calculator problem. And we would end up getting the following answer, about 1.6744. Go ahead and move on to our next question here. Number 26. So we want to, once we have our exponential piece all by itself, which we do in this case, we want to get rid of the 20, and we do that by, once again, logging both sides with that base. So in this case, these cancel out. We have 5.3 minus 4r. And on the right side, we're going to be doing the change of base formula. So we need our calculator for that. And I get 1.683 approximately. And in this case, we actually have a little bit more work to do because we get that r by itself. So I'm going to minus 5.3 on both sides first. And for that, we get negative 3.617. And then finally, we're going to divide both sides by negative 4. So by doing that, we will get our final answer, which is about 0.904. Okay, so the steps are just to log both sides and solve for r, right? Let's go ahead and take a look at another one here. Okay, number 27. All right, so what makes 27 unique is that here's my exponential part, but before I can do my logging to get rid of that, I have to get rid of this negative 3 and 8 first by just doing some basic algebra here. So we're going to start by subtracting. Gives me negative 80. And then I'm going to divide both sides by a negative 3. And I think I'm just going to go ahead and turn that into a decimal now. All right, so once you got those non-exponential numbers out of the way, you're ready to go ahead and continue with the process that we've been doing, which is we want to get rid of the 15 by logging both sides with that base. All right, so on the left side, these go away, and I'm left with r. And on the right side, we're going to go ahead and do our change of base formula. And by punching all that in, we should end up with about 1.2125. All right, let's go ahead and move on. 28. Oh, we already see the answer there. Don't cheat. Let's go ahead and try it anyway. I'm going to add 3. Once again, it's a lot like the last problem. There's really not anything new or interesting here, right? But we'll go ahead and go through it anyway. Get rid of that 9 by division there. This is an interesting one. Now, you could log both sides, but, well, let's go ahead and do it anyway. Log base 7, log base 7. On this side, these two things cancel, leaving you with negative a minus 8. On this side, I wouldn't think of these things canceling out, although they do in a sense, but one of our log properties tells us it ends up being 1. So the reason it's 1, if you want to go with the canceling approach, is if you think this has a power of 1, then when these cancel, you're left with 1, but there's your result there. So we're going to add 8 on both sides, like so. And then we're going to divide both sides by a negative 1. And then we end up with a is equal to negative 9. Final answer. Continue onward. So we're going to get some word problems, and as you guys know, there are 3 types of exponential functions you need to be ready to know how to use and when to use. So we have the general one. That's a horrible way of writing the word general. Let me try that again. There we go. We have the compound interest one. It's supposed to be an I. Getting lazy here. The compound interest one is A equals P times 1 plus R over N to the NT. And then finally we have the continuous compounding problems, or continuous growth. Could be called 2 different things, which look like this. And in those cases, the R can be positive or negative depending on whether the function is increasing or decreasing. So when you're reading your problems, you got to think, what kind of a formula would I use? And then after that, you plug in the information that they give you. And then after that, you just solve the equation. So let's read it. If the amount of a toxin in the bloodstream is metabolized, that means it's decaying or decreasing at a continuous rate, ding, 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 that means we're using this formula down here, at 20% per hour, how long will it take for half the toxin to be left in the bloodstream? All right, so since this is a continuous problem, we are using this formula. Y represents the final amount. P represents the starting amount. R represents the growth rate. T represents how long this is going on for. T is the thing we're looking for, so that's going to stay as T. Now, I have my 20% here. That's my R value. So R is equal to 20 over 100. But notice it's decaying, so it's going to be negative 20 over 100. So negative 0.2 would be my R value here. They don't tell me my starting amount, so we'll just leave that as P. But they do tell me that the final amount is half of the original amount. So in other words, half of P. Okay, so we have all that stuff. So if we plug these things in, I'm going to replace the Y with half of P. I'm going to leave the P there for now. My R is negative 0.2, and then my T goes right here. I'm going to divide the P out on both sides. And I'm going to change this to a decimal just because I prefer it to be a decimal. And there we go. So once you've got it to this point, you're just going to solve this equation using the methods that we've learned for solving exponential functions. So here's my exponential function here, and I want to get rid of this e so I can start getting the t by itself there. And the way we're going to get that e out of there is by logging both sides with a ln. So on this side, those cancel out, and I'm left with negative 0.2 t. And on the right side, I've got ln of 0.5, which we'll need a calculator. And I get negative 0.693 for that. And then we're going to divide both sides by negative 0.2. And that will give us our final answer for t. And that's 3.466. And so that's how long it would take for half of the toxin to be left in the bloodstream, is 3.466 hours. All right, let's go ahead and take a look at another one. If you invest $100 into an account that gives an annual percentage rate of 25% that's compounded monthly, that's important to be aware of, compounded, and monthly is also something. How long would it take for you to earn $200? Starting amount is 100. There's my percentage. So notice it's compounded monthly. That means we're using this A equals P times 1 plus R over N to the NT formula. The 100 here represents the P value. The 25% will help us find the R. And with these types of problems, it will always be positive, but you do need to divide it by 100 still. Monthly tells me that my N is 12. That's how many times it's being compounded. And then finally, the 200 tells us what the final amount is. So A is equal to 200. So plugging all these numbers into this formula here, we would have the following. You would have 200 equals 100 times 1 plus 0.25 over 12 to the power of 12 t, which is the time. And t is what we're looking for, so that's what I'm trying to solve. So let's go ahead and begin here. I think I'll go ahead and make some room for myself here. All right, so step one is going to be to do, well, we could probably simplify this first real quick. What's 1 plus 0.25 divided by? And I get 1.021. Next, I'm going to get rid of the 100 by dividing that off of both sides. 100 goes into 200 twice. And then to get rid of the 1.021, I will need to log both sides with a base of that value. So let's do that. And so on the right side, these cancel out, which was my goal. And then on the left side, we're going to have to do change of base. We're going to do log of 2 divided by log of 1.021. So we'll turn to our calculator for that. See what we get. And that gives me 33.352 is equal to 12t. Finally, we'll divide. And that will give me my final value there, which is 2.779, and that would be years. So it would take that long for $100 to turn into $200 with an annual percentage rate of 25% compounded monthly. That takes a long time just for $100. All right, let's go ahead and move on to the next set, which is graphing. So to graph a logarithmic equation, the first thing you're going to do is you're going to find the vertical asymptote, which can be found by doing your domain. So we do 2x minus 4 has to be greater than 0. I get x is greater than 2. And that means on my graph, we're going to have a vertical asymptote at 2. Another thing that that's useful for is for helping select my next points. I'm going to pick some numbers that are greater than 2. So let's go ahead and go with 4. And we also want to pick another number that's a lot bigger than 4. And the way I did it in the notes was I always picked a number that was 10 units bigger than 4. So that would be like 14. And then what we do is we just plug it in to find out the y values that go with those x values. And we'll plot the dots and connect the graph. All right, so 2 log base 4 of 2 times 4 minus 4. So I'm plugging in the 4 first. So 8 minus 4 is 4. And that's kind of convenient. We have a nice quick rule for that. And now if you don't have a nice quick rule, of course you can always do change of base. But we have a nice rule for that. Anytime this number matches this, the answer is 1. So that worked out nicely. Saves me a little time. Get negative 1. All right. Now we got to do the same thing for the 14. I doubt that one will turn out as clean, but we'll see. So that's 28, take away 4 is 24. And so that's one where I would have to use the change of base. So we'll do log of 24 over log of 4 there. And for that, we will need a calculator once again. Get 2.292. Then we'll go ahead and multiply these together and then add 1. Let's see what we get for that. And I end up getting negative 3.5 5 approximately, a negative 3.6. And then we're ready to graph it. So my x-axis needs to go out to 14. My y-axis needs to go down to negative 3.6, so I'll just go down to negative 4 there. And so at 4, my y value is negative 1. And then at 14, we're at negative 3.6. So we can kind of see the trend. The graph is going in this direction. And there's my logarithmic function there. Okay, so once again, find your domain, make your vertical asymptote, pick some x values, find the y values, plot the points, and connect the dots. Let's go ahead and take a look at one more of these types of problems. This one's an LN problem. All right, so for this one we have 2 minus x is greater than 0, minus 2 on both sides. Reverses my inequality, so that means x has to be less than 2. So I'm going to go out to 2 here, draw a vertical line at 2. And whenever I do my table here, I want to pick values of x that are less than 2. So I'll start off with 4, and then I'll do 10 more than that, which is 14 again. And we'll just plug it in. All right, so plugging in the 4, first of all, we end up with 2. Well, actually, I need to pick numbers that are less than 2. I did not pick numbers that are less than 2. Shame on me. I picked numbers that are greater than 2. So numbers that are less than 2. Let's go ahead and pick 0, and let's pick negative 10. There we go. That'll work out. So ln of 2 minus 0 is ln of 2, which we're going to need a calculator for. And that gives me approximately 0.7. And then we'll also plug in our negative 10 here. 2 minus a negative 10, which is ln of 12. And once again, got to use our calculator for that. Don't need to change a base, though, because we do have an ln button on our calculator. So for that one, I'm getting 2.5, and we'll go ahead and plot these dots. So at 0, my y value is 0.7, and at negative 10, my y value is 2.5. So I need to go out to negative 10 on my x-axis. And my y-axis needs to go up to about 3. So let's go ahead and graph these. At 0, we're at 0.7, so I'd be like right about here. And then at negative 10, we're at 2.5, which is going to be like right about here. And from that, we can see the trend is looking something like that. And there's that logarithmic function. All right, so that does it for the study guide. Hopefully that was helpful. See you guys in class to see what you can do on your test. Have a good one.